Okay, welcome back. This is going to be the second part of functional JavaScript, making JavaScript more functional. So the last time I was with you, we looked at API sauce, which is a wrapper around Axios. And let me just see if I can pull that up. API sauce. Okay. So this is what we were looking at last time. The first video, we kind of dove into the issues here. We looked at some issues. We looked at a little bit of code. We did kind of like a high level, quick overview of things. And then the second video, we looked at starting to refactor a little bit. It was not the definition. I think it was in library, API sauce. I think it was this, yep. So we looked at this file and we took a look at the we took a look at this get problem from error, just basically some if statements. We were looking at these status codes and thinking, okay, this may grow, it may not grow, but if it does grow, right, we don't want more cascading ifs. We want to just kind of convert that. So we converted it into a cond function or a condition function, which is basically a composable switch, a more functional composable switch type construct. Um, and it's just a more natural flow, I think, for cascading ifs to grow, because ultimately that's a list of lists, and uh, you can just build up that list. That list can be stored in a database. That list can come from anywhere, and it could just be thrown into cond and evaluated. So I like that. Um, there's obviously different places where you could take it further from there, but that's just kind of what we looked at. We ran that in run.js in the REPL, the JavaScript REPL, which was cool. And then we kind of ended up saying that, yeah, this create function is kind of next, right? Uh, there is, yes, there's a lot going on here. There's some things that we can do. Yeah. And I'm trying to keep these videos at least to an hour or less. So we will probably not be able to get through all of Create today, but we will try to tackle what we can, and we'll check our time, and we'll make sure that we keep it to an hour at the most. Okay. So I think for this, I think this is going to be too much for the REPL, unfortunately, for Run.js. I think we're just going to have to do a full-blown editor. I think we're going to have to pull out cursor and pull this code down. Yeah, it has test here. And run some of these tests so that as we're modifying this to make it a little bit more functional, we can rerun these tests and make sure these tests still pass. And that gives us the confidence that our changes are actually good changes, and that they don't effectively break in any sort of major way. And we'll just use that as our guide as we go along. Okay. All right. So let's start by pulling this down. I'm going to open up iTerm for this. Let's make some space. Hopefully that's big enough. That should be big enough for you to see. And I want to grab the this, and we'll just do a git clone on this. Yeah. All right, cool. So API sauce. Let's clear this out. All right, so we have API sauce here. I'll just pull in the dependencies. Oh, is it? Nope. JavaScript npm install. Okay, that was it. But we have an issue. Override type mismatch conflict with direct dependency. I wonder if this is. I wonder if there's something in the package.json. I wonder if there's something in there. Let's see. Oh, yeah, right there. So it has a problem. I think it might have a problem with this because it's a mismatch. And this is, okay, so I think I have 305, it's requiring 304. I should be able to remove this. Now that we've pulled it down, let me open up cursor so we're not doing everything in the terminal. Okay. And API sauce, this is the folder I want. Okay, I don't want this chat window. Close that. And, okay, so let's see. Package.json. Let's take a look where that overrides is. Okay. So I think I should be able to just remove this, save that, clear this out, and try to pull in dependencies. Okay. That seems to be working. I don't know how long this is going to take. But we'll give it a little bit of time. I am on a Wi-Fi connection, but I'm in Hawaii, so when you're on an island, sometimes things just take a little longer. But I'll give it a few more seconds, and then if nothing, okay, here we go. Warnings, I'm okay with that. For what we're doing, I'm okay with that. Okay, cool. So it's working. We got some undefined warnings. I'm okay with that. I'm okay with these warnings for what we're doing. Okay, so that's pulled down. Great. Now, let's go back over here. I'm sorry. Let's go back to cursor. We can close this now. We're good with that. And we want to come into, not the data definition, but lib? Yeah. Okay. Let's give ourselves a little more space. No, okay, we're good there. All right. So this is the file, API sauce. I'm just going to collapse some of these things down that we don't really need right now. Okay. We looked at that last time. We looked at that last time. And here's our create function. Okay. So, all right. So we are, like I said, there's a lot going on here. Um, I'm okay with this. I'm totally okay with that. That's good. Um, we're just doing a spread. If if there's headers, then we're going to use those headers. Otherwise, we'll just put in an empty object. I'm okay with that. It's this part right here. So we're creating an instance. And this is very normal JavaScript code. You're going to see this. I don't even want to call it a pattern, but it's more of a style where it's you're creating an instance, and then based on some conditional, you're assigning you're creating a new instance and assigning it to that, right? That's fine. This is fine, and this works, right? But again, our purpose is here is to try to think about this from a functional perspective. We want to think about the data. We want to think about things like immutability. Here, this is okay. We are doing assignment, and so we're doing a binding, which is okay, right? In functional programs, especially in JavaScript, we want to sort of focus more on like rebinding things. It's subtle, but so you might look at this and think, well, okay, this is mutation, and you're right, it is. But another way to think about it is assignment, just assigning a value to a variable. In this case, it's a variable because it's a let, but if it's a const, like up here, you're assigning a value to a binding, something that's a little bit more solidified than just a let. But in either case, you're creating a value and you're assigning it. And that, in and of itself, is, especially in JavaScript, is fine. It's the problem, the thing that we want to avoid and try to stay away from is when you go inside a structure and you're changing the data, you're changing the data structure itself, like this push does down here, right? Um, it's that kind of thing that you want to try to stay away from. This is okay. It's just a little bit noisy to me. We're using if else structure. This is not very FP. This is more, traditional procedural OO type thing. And for me, I'm about, and for functional programmers, we're about clarity. We're about concise uh, expressions, and that doesn't really read well here. So, uh, what we could do is before I change this, let me just see where else it's being used. So, instance is being used here, here, and here. It's being returned out of here, and we have to remember the structure here, right? This is a function, but it's ultimately returning an object, and that object is basically the API that consumers of this API sauce are going to use. They're going to create this object, and then they're going to have internal state, which is to monitor these transforms. Uh, they're going to have these convenience methods like set headers, right? And it's just going to be sort of like a traditional class in an OO sense. And so that's kind of what we want to keep in the back of our minds as we're kind of going through this, is that yes, that might be the overall structure of things, and I wouldn't necessarily do it that way from the beginning, But I didn't have the luxury of coming in here from the beginning to do this. I'm coming in here at this point and saying to myself, how can I make this more functional? How can I move it towards a more functional approach to eliminate mutation bugs, to eliminate to make it more accessible for redesign later, these types of things. That's what I'm thinking about. So I have to keep that in mind. Plus, we don't want to break. We want to try to avoid from breaking consumers who already have code written that rely on this API. So they rely on the fact that they call this create function, they pass in configuration, and they get back an object with internal state, and their API is already written for that. We want to try to avoid breaking them as much as possible. Ideally, we don't want to break them at all, but we may have to, and that's okay. If there's small little changes that they have to make to upgrade a version, we document that in the GitHub repos and any other external sites that have documentation, then we're good to go. We can make these changes. They might have a little bit of a break, but ultimately, they're getting a better product. They're getting a better API. Um, yeah. So let's just look and see where instance is being used. It's being used there. It's just being returned, returned, returned. Okay. Okay. It's just being accessed here. That's fine. Um, and it's just being returned here and then down here. Okay, so this is an Axios instance that we are working with. Okay, so since it's only ever being assigned once and then accessed into one time and then but ultimately just being returned out of here, that's good. That allows us to, well, let's, before I start to make these changes, I want to look at tests. So let's see, here's the tests. Okay, so we have test here. Let's just try to run the test. What is the testing framework? What test are they using? Let's see. Oh, Ava. Okay. Hmm. It's been a while. Have I even used Ava? I may have used Ava. I don't know. It's been a while. Let's see. JavaScript testing Ava. Okay. Alright, let's take a look at this. Oh, bump this down a little bit. Okay. No, I don't want to do that. Okay. So, test runner. Okay, concurrent tests, atomic tests, no implicit globals. Interesting. Okay. All right. So I did this with kind of everything. So Ava should technically be there, and then just npm test. Okay. So let's try to run the test because technically it should be here. We have a test folder. So if I just do npm test and it's np, yeah, I should be able to. Okay, cool. So I just want to run all the tests. Oh, nice. 71 tests, all passed. Great job, API sauce contributors. Love to see that. Okay, so all the tests pass. I can close this. Don't want that taking up a lot of CPU cycles. All right. Okay. So all the tests pass. And let me just reopen API sauce and get back down here. Is there a... okay. Config test. So this is the create function that we're looking at right now. This returns an object, configures Axios correctly. Okay, cool. So we are able to run this to test the create function that we're getting ready to change. Right, so let's try this. npm test, and then I'm gonna try config. I'm just gonna try to point this and see. That should work, but okay. Let's try. Let's try npx ava, and then the path. Okay, cool. All right, so for tests passed from the config, let's make sure 1, 2, 3, and 4. Yeah, cool. All right. So now we know that those tests pass. So the only thing I want to do in here is just kind of try to clean this up a little bit. So I'm going to const instance. Okay, so just to recap here, config, we're checking to see if config.axios instance is true, if there's something here. If there is, we want to use it. If not, then we want to create config without headers, which is just the config we pass in, and headers explicitly marked undefined, spread out in an object, and then we take config with headers, okay, and we pass in default config. What's default config? Just out of curiosity. Oh, okay, it's just a timeout. Okay. Okay. And so we're basically building up this object, config object, and then we're passing that into axios.create, and then we're assigning that to instance. So, okay. But this and this is really doing this. This is doing the same thing. You could just inline this right here, right? And this if else could just be a what's it called in JavaScript? I think it's like a null coalescing. It's just coalescing, right? So you could do in config.axios instance like this, and then do that, right? So this right here is going to do the check, which is this, and then if it's true, it's just going to use this, which is this line right here. And then on the right-hand side, so if this is false, then it's going to use what's on the right-hand side, which is effectively this. So axios.create, right? And then in here, just inline this, right? Just default config, and then instead of config without headers, you just continue to inline this. Config that's passed in, and then the headers, headers that is explicitly marked undefined. All right. So let me just comment this out. All right, let me save this. And this is TypeScript, so we'll have to recompile. I think it's TS TypeScript compiler, so I think it's TSC, if I remember correctly. I'll try it. Let me just see if it's here. Is it here? My bad. Let me see if it's here. Okay. It is here. npx tsc, and then maybe, I don't know, help? Yeah, okay, it's here. And builds a project, or I could do it the -b, compiles the current project. Okay, so yeah, TSC is fine. Cool. So npx tsc will recompile the file I just saved. And so now I should be able to rerun the test, config test, to see if we're still good there. And we are. Okay. Cool. So now, yeah, we can just, okay. All right, so that's cleaned up. So the next thing is monitors. How am I doing on time? Should be okay. Let's check. Okay, not too bad. Almost 30 minutes. Okay, so the next thing is monitors. There is a monitors test. Let's try to run this. Attaches a monitor. Okay, so we have a before and after where we're getting, okay, ports, creating a server, getting a port, cleaning up after on the server. Cool. Attaches a monitor. Okay. And then we're running the create function, adding a monitor. Looks like there's 1, 2, 3 tests in here. Let's just run it and see what we get. So npx ava test, and then I want, it's called monitors, I believe, monitors.test monitor, test.js, like this. Okay, cool. All 3 tests pass. And it looks like monitors are, yeah, they're just functions. Yeah, they're just functions. So they're just functions that are being added to this array, right? Some more functions getting added. This one, okay. Reckless. Okay, so that's not defined anywhere. So this is essentially, we're just trying to, I guess they're just trying to add a function that is going to throw, maybe. Okay, add monitor. Another one here. Okay, so all these tests pass. And, you know, when I'm looking at this, this is what I was talking about before. So the monitor.push, this actually takes the array at this location and mutates it in place. It changes it in place. And that's not what we want as functional programmers. We actually want to be able to just create uh, in terms of adding a monitor, we want to be able to take a single monitor and we want to take that single monitor and put it in a new array that we create with the existing monitors that we already have, right? And we're kind of just exposing monitors here so that it can be used here, and then it's also used here. And I know that it's here because if I look over here on the side, there's these gray dots. And so I'm just scrolling to the dots because that's where monitors is in this file. So that's, if you're wondering, like, how does he know it's down there? I'm just looking at that. So it's being used here. They're just for eaching over that, running that, and ignoring, yep, any errors that are thrown here, which does make sense, I guess. I guess it kind of makes sense, right? Because if monitors are just functions, the user of the API, of API sauce, is adding these monitors. So they're adding functions to API sauce. API sauce is just going to run them at the right time after converting from Axios response. It's going to run these functions. If any of these functions have a problem, that shouldn't be that shouldn't be API sauce's issue. That's more of an issue for the caller or the consumer of this API. So that kind of makes sense. You could handle it better, but this makes sense. And then we have one final thing here. Okay, so monitors, see this, the actual array itself is being exposed. Yeah, because we're returning sauce back. So this is the whole object. This is everything. This is monitors. This is the instance. This is everything. These convenience methods. And so we're just tacking the array right on that internal state. We're just tacking it right on and giving it to the caller, right? Because this is effectively, yeah, config. We just return that instance back, or return sauce back. Okay, so since that's the case, I think we're going to have to break this, because right now users are able to, and we could probably prove this in the test, right? So right now users will call, they'll call the create function, get back an instance, and then they just dot into monitors, and then they access all those monitors, all those functions, right? They call add monitor to add a function. And that's going to have to change if we want this to be a little bit more functional. So this will need to change and be an accessor method, like a get monitors, I'm thinking, because we don't want to expose this like this, and we don't want to mutate it like this. So what we really want is, again, if we're thinking about how we can preserve this API, preserve callers, we know we're going to break callers because we'll probably need an accessor method, but in terms of making this a little bit more functional and not having this mutation, again, normally I would be using libraries like Lambda and some other techniques here, but because this is an object that has internal state, we just want to make that as functional as possible, and we don't want to break too much the public side of this. I think given those parameters, I think the best thing we could, maybe not the best thing, but the initial thing I'm thinking of is just having a container for state. This is sort of like a ref cell. If you know about OCaml, if you know about F#, even if you know about, this is the same thing as the state container in React, right? You want some sort of a container around the actual state. And then you just want to update or reassign to that internal state inside that container. So what I mean by that is maybe introducing something like uh, state here, which is basically just going to be an object. And then inside there, you would have monitors like this. Okay? So it's essentially the same thing, but we're just putting it inside a container. So that container, because ultimately I think this container will need to hold these other ones as well, like all these other exposed arrays. So like request transforms would need to be this, right, etc. And we just need to go down the list. But for right now, we'll just focus on monitors just to kind of get the juices flowing, to just kind of get a feel for this refactor. Okay, so we have state here, and we don't want to push, right? What we want is we want to just access. We want state.monitors to be a new array that contains the current monitors that we have plus the new monitor. That's it, right? This allows us, this is creating a new data structure, preserving the previous data structure, data from the previous data structure, and then rebinding, and then binding that value to here. We're just eliminating mutation at the data structure level. Okay, so let's do this. That's going to break these dependencies here. So run monitors, this needs to change to state.monitors, like this. And then down here, we can't actually expose this. Like I was saying before, we can't expose the monitors directly because it's tied behind state. We don't want to expose that state. We want to expose a function that computes the value, the current value of that state, right? So here, the way we can do this, and this is going to break, but we'll see if it's a big enough break. I don't think it is, but so we can create get monitors as our accessor. All it's going to do is grab the state of the monitors, right? So state.monitors. It's just saying, give me the monitors that are currently in the state. Okay? So now, down here, we want get monitors, and that's going to be exposed on sauce and returned for our instance. Now, we're introducing a new function here, and we're not exporting, but we're effectively changing what is returned from the create function by adding another function here to it. So we might need to change the definition of the TypeScript file. Let's go look and see. Okay, so there's our create function. Okay, so here's our monitors, which we are no longer going to use, here's our add monitor. So we need, let's just, let's just go ahead and do get monitors here because we added that, right? Get monitors doesn't take anything and returns an array. That's fine, that should work, but since add monitor takes type monitor, this is going to return type monitor array, right? So that's probably better. Save that. Okay. All right. So we've made that change to the definition. We've made this change. So now we want to come into the tests. We're going to have to make changes here, but let's just first compile and see where we're at. Okay, I think we're still good there. Our test should fail now, actually. Let's just confirm that. Yeah. Yeah, so we just ran this. 2 passed and 1 failed. Oh, interesting. Yeah, so it's having this issue with monitors, which is what we expect, right? Okay, so let's just come back over here into the test now for the monitors. That's crazy that it's working. That 2 tests are passing when I run that. Clear monitor. Yeah, huh. Two tests are still passing, 1 failed. I don't know, I'll figure that out. But and it looks like the test attaches a monitor is what's failing. So it's saying that these are passing. Oh, okay. Okay, that does make sense. Add monitor is the same. We just made it a little bit more functional of how monitors get added to the state. And so attaches a monitor, we add a monitor here, and then okay, so it's accessing monitors directly. We're not doing that anymore. We're actually doing get monitors here. So that's going to give us back all the monitors. And then here, we're not accessing it to determine the length. So get monitors here. That will give us the length. Then we're adding again, and then we're doing the length again here. So let's look at get monitors here. All right, so this is basically the change in the API that the user would see. So instead of getting the API and just dotting into monitors, we're calling an accessor method to get monitors. It's a break. We're breaking the API a little bit for this, but to me, this is fine. This isn't too big of an ask. So I'm going to save that. I'm going to rerun the test. Okay, so now we're good. So that's great. How are we doing on time? 45 minutes. Okay. About 15 minutes left. So, okay, so monitors is effectively pulled into state, right? And we can safely get rid of this. We have an accessor method get monitors and add monitors, good to go. And ultimately, we would do the same thing here for these transforms. But this is going to be more involved, especially from, let me look at the test. Yeah. This is going to be more involved if if I tackle this now, I don't have time to tackle this now, but maybe in the next video we'll look at it, we'll tackle it. Let me look at these headers. Okay, maybe I can, okay, let's look at these headers. So we could change these headers as well. This is very similar to the monitors that we just looked at. Let's see, headers, tests. How many tests do we have here? Oh, just one test, okay. Okay. All right, headers. So let's try and run headers right now. Okay, headers pass, one test, cool. All right, so if I wanted to, just looking at this, name and value. We're passing in a name and a value, and we're just, again, modifying the headers data structure. That's the mutation that we're trying to avoid as functional programmers. So we want to look at headers. Oh, it's defined. Oh, it's a constant. Okay. That's okay. Okay, so if we want to create a new structure here for headers, because when you add a header, you will need to effectively change this object in some way. And there's a way to do that functionally in JavaScript. But with this constant here, we won't be able to rebind it, right? That part will fail because this object at the top level, at least, not the nested levels, but the top level, this object is going to be essentially frozen, essentially immutable. So, but we want to reassign the whole thing. So we could make this a let. And again, this is only, again, we're just trying to preserve the API, and we're trying to move away from data structure mutation. Mutation in this sense of reassignment of value to a binding, totally fine. That's totally fine. We do that all the time in functional programs. So making this a let is okay. I'm going to save that. And now I want to try to tackle this set header. So we're taking a name and a value. What I think we could do is, now that it's a let binding, we can say, okay, headers is now going to be a new data structure. That new data structure is going to be headers, right? And it's going to be name and value, like this, right? And then that's it. We still return instance, but we're not mutating headers. We're creating new headers and rebinding. So we could do that there. Save that. Looking at set headers, we could, well, yeah, headers. Again, we're taking headers. These are bulk headers, right? So these are multiple headers, not just a name and a value. So we could here, existing headers again. We want to preserve that. Wait, existing headers is actually going to be this existing headers. So we need to change this headers because that's going to shadow. That may shadow. We'll just call this new headers now. So now preserving the existing headers and then spreading out the new headers, right? So you don't really need this. You could just do that. And then deleting headers. Again, headers is going to be a new object that we want to create. So 1 second. Okay, sorry about that. Got interrupted. This happens when you're working, right? As engineers, developers, people are going to interrupt you. Okay, so left off. Yes. So we did the set header, the set headers, and then delete header. Right. So headers, we want to remove a header. This is going to be a little bit different. We want to actually pattern match out. I'm sorry. We want to destructure. We want to destructure the name that is at that location, right? And then we want everything else in the object. So we want it. So this is basically this name that's coming in is the name and the value of this particular property in this object at this location. And that's the thing we don't want anymore. We do want everything else in the object though. So this is just pattern matching that part out. And then it's saying we want to capture everything else in the object as rest. And we want to capture all of that from our existing headers. Okay? Now, instead of that, we now want to say our new headers is going to be equal to rest. Right? Because that encompasses everything except this name and this value that we want to get rid of. We could do that. I don't really remember the syntax. I think we should be okay here. If we're not, it'll break, the test will fail, and we'll figure it out. But I think that's okay because we're just capturing rest and then we're using rest here. I mean, if I need to, I don't think I need to do that, but it's been a while. Okay, so that's delete, that's set headers, and that's set header. I think that's it. Headers, I'm not changing it anywhere else. So let's save, so we save this. Let's compile. Okay, TypeScript compiler. We're still good on the compilation. So let's rerun headers tests. All right, test still pass. So we are good there. Yeah. So this is just kind of, again, let me just check on the time because I think I probably need to wrap this up. Yep, 53 minutes. All right, so just to kind of recap what we've done here. We pulled everything down from API sauce because this is getting more involved now. We're working in this create function, which is kind of the main function for API sauce. We looked at the instance, which had that if-else branch, and we're just like, this could be a little bit more concise. And as functional programmers, we're striving for expressions. We're striving for to be concise, and to not have a lot of noise in what we're doing, in code we're writing. So we cleaned that up. We identified that a lot of these arrays are used as internal state, but the actual data structure itself is being mutated. So we don't want to actually mutate directly. We want to just reassign. And we, again, just kind of taking a lesson or like a chapter from other functional languages like OCaml, F Sharp, Erlang, Haskell even, Clojure, and even React, which is where React gets all that from. It gets it from those other languages. And that's just, not exposing the state, but wrapping a container around that state, a ref cell, and then accessing the value in that ref cell. And that's all we're doing here. But we're making sure that we're always creating a new value as we're updating the internal state. Okay? This breaks monitors because monitors was exposed to the caller because they have to be able to add functions and get those functions. So instead of dot monitors and exposing that state and having the user access that state directly, we're basically just introducing an accessor method, get monitors. Okay, and we added that to our type definition here. Add monitors now updates the monitors in a more functional way. And then we determined that request transforms was just, too involved for what we're doing. We don't have time to really get into that now, but we'll get into that in the next video. So we came down here and noticed, okay, the headers, and I should also mention before, we made sure that our config tests still ran after we made those updates to that instance. And the monitor, we made sure that all these tests still ran after we made updates to the monitor. We had to make a slight change, again, get monitors instead of monitors, and then we came over and we saw that we had time to address headers to make it more functional, very similar to monitors where we're creating a new value and we're reassigning. And in order to do that, we had to change this headers from a constant to a let, which again, I'm okay with. We're keeping internal state in here. We're just trying to make sure that that state is just being assigned and that we're not mutating the data structures. So that's okay. So we're good there. Went down too far. And we're just using the spread operator. We're just making use of the spread operator here when we're creating new values, where we're creating new headers, whether they be individually or in bulk. And then when we're deleting, we're just deleting the thing that we want to delete. We're capturing the rest of it, and we're just rebinding the rest of it to have that be the new value for headers. Okay? All of that stays the same. There's no API breaks from the consumer level when it comes to headers. We verified that by running the headers test, which there's just one. This test still passes, and so we're good. I think we'll end it there since I am out of time. We are right at an hour. So I'll end it here. And like I said, next time we'll jump into these request transforms. We'll jump into some of these tests to verify as we make these modifications or this refactor, that everything still works. And what you'll actually see me do is just, like I said, start to add these transforms in here and have them be a part of this state. And I think this is a little bit more logical as well for readers of this code. Right? So I'll leave it there, and I'll see you in the next one.